Hello everyone, Mr. P here. Today, we're gonna factor using the difference of squares. Okay, so before we get into the difference of squares, gotta review one thing of what a perfect square is. Okay, so perfect square is a number or a term that can be square rooted such that you don't get a decimal. Okay, so circle the perfect squares here. So we're gonna circle 9. And because we know 9 is a perfect square, because if we square root it, you square root 9, you get 3, which is a whole number, so it works. 5 will not be a perfect square, because if you square root 5, you get some decimal number, not good. 36 will work. 36 is a perfect square, we can square root it, and you get 6, right? And it helps you sometimes to go backwards to realize that it's a perfect square, right? 6 multiplied by itself, 6 gives you 36, right? Remember, squaring, or the exponent of 2, is the opposite of square rooting. 144 is a perfect square. If we square root this thing, we get 12. And again, going opposite, 12 times 12, you get 144. 134, if you square root that, you get a bunch of decimals, not good. 625, square root that, you get 25. So this is a perfect square. We get 25, and again, going backwards, 25 times 25 gives you the 625. Okay, 70 is not a perfect square. Again, square root it, a bunch of decimals. 49 is, square root it, you get 7. 1 is a square root, because if you square root 1, you get 1. And that works backwards as well, right? 1 times itself, 1 is also 1. Okay, these last three are a little bit different, but same idea. So these last three are variables, but same thing. You have to be able to square root it and not get a decimal. Okay, so x squared actually is a perfect square. Because if you square root x squared, you actually end up with just x, which technically has an exponent of 1, you just usually don't write it, right? And if this makes more sense going backwards, right? Because if you multiply x to the 1 by itself, or x times x multiplied by x, we know that you normally add the exponents. And since the exponents are 1 and 1, you end up with x squared there, which is what we originally started. Therefore, it's a perfect square. X to the 3 will not work, right? If you try to square root of 3, it'll be a decimal number there. Okay? The last one, x to the power of 4. This will be a perfect square. If you square root x to the 4 and ask yourself what variable multiplied by itself gives you x to the 4, the answer would be x to the power of 2. Okay? X to the power of 2 times x to the power of 2. Remember, when multiplying variables of the same base, you add the exponents. So of course, 2 plus 2, you get 4. So x to the 4. So those are our perfect squares. Okay, now let's hop into difference of squares. How to factor difference of squares. So the question would give you something that looks kind of like this in the form of a squared minus b squared. It won't necessarily look like that, but we'll convert it and visualize it to make it look like that. And then you need to identify your a's and b's, and then you basically put it in this pattern over here, a plus b in a bracket, a minus b in a second bracket to factor this thing. Okay? And you're going to see where the perfect squares come into play. So let's erase this for now. So this is our question here. We're going to factor 49x squared minus 1y squared. Okay? So the first term in our formula is a squared. That means that's going to be equivalent to the 49x squared here. Okay? So a squared is equal to 49x squared. Okay? And we basically want to find the value of a so that we can put the value of just a there and the value of just a there. Right? Because as is, this whole thing is a squared. So if a squared equals something, and we want to find out what just a is, we got to get rid of the square to the other side of the equal sign and do the opposite. Opposite of square is square root. So that means a will be equal to the square roots of 49x squared. And this is where the perfect square comes into play. We're basically checking right now to see if 49x squared is a perfect square. And it actually will be. So if we square root this thing, square root of 49 is 7. And square root of x squared, like we just talked about, is x. So that means now that our value of a is equal to 7x. Okay, so far so good. Let's do the second part in blue. So our second term is b squared. We're going to ignore that negative in the middle. We just need to have that negative there to make sure that this is a difference of squares, but we're going to ignore it. We're just going to look at the 81y squared. So these terms are essentially equal. So that means b squared is equal to 81y squared. Ooh. So same thing like with the a, right? We want to check if 81y squared is a perfect square. So we're going to get rid of the square, the exponent, bring it to the other side, and square root this thing and see if it works. 81y squared, 81 will get 9, because 9 times 9 is 81, and square root of y squared is just y. So it did work. It is a perfect square. And that means that b is equal to 9y. Okay, so now the last step is super easy. Now we just need to fill in this pattern. We know what our a's and b's are. So if this was our question, we can automatically go right to our factored answer. We can make our brackets. We're going to put a first in both brackets. So we know our a value is 7x. So we're going to go 7x there, 7x there. And notice each bracket, one has a plus, one has a minus. So we can go plus, minus. And again, technically the order there does not matter. You can flip them if you really want to. And then our b value finishes off each bracket. So our b value we know is now equal to just 9y. So we go 9y there and 9y also there. And that right here is our answer, our factored answer. 7x plus 9y, 7x minus 9y. Let's do another one. Factor difference of squares. Again, I got our pattern up here. We can mimic here, but we're going to factor 16a squared minus 25. Okay, so let's get a red first. We'll start with red. So our a squared term is known as going to be equal to the 16a squared. So let's start with that. A squared is equal to this. So we want to see if this is a perfect square. Looks like it will be. That means we solve for a and we square root this side. 16a squared. And square root of 16 is 4. Square root of a squared is a. So that works. Our value of a is 4a. Easy. Now let's check the b squared again. We're going to ignore that negative, that minus for now. So b squared is equal to the full value of 25. This one is definitely going to be easy. So b squared is equal to 25. That means if we solve for b and square root that, we get a 5. That one was pretty nice. So that means b is equal to just 5. So last step, to get our answer here, just got to fill in this pattern. So make our brackets, right? Just like this. We go a's first in both bracket. So a is 4a. A is now equal to 4a. So we go 4a. And we go 4a. Sorry if my a's look like 9s. And then we go 1 plus and 1 minus. Again, the order doesn't matter. So plus and minus. And then we finish off by placing the b's there. So our b is just straight up 5. So go 5, 5, done. So that right there is our factored answer. 4a plus 5, 4a minus 5. Easy. Let's do one more. So sometimes you need to remove a common factor before you can solve your difference of squares. Okay? And any point in time when you're factoring anything, you should really always common factor first, because at the very least, you simplify your numbers. Okay? So here, it looks like our numbers 16 and 36 are actually perfect squares, but if we common factor this, we'll be working with much easier numbers, right? And this comes more into play when you're dealing with numbers in the hundreds or the high double digits there, okay? So 16a squared minus 36b squared, it looks like we can take out a 4, right? So we can divide this out by 4. So we take out a 4, and we divide these by 4. Then the first term, 16 divided by 4, becomes 4. It still has the a squared with it. Minus is there, and then 36 divided by 4 becomes 9. So it's 9b squared. Okay, so just like other factoring, you save this 4 on the outside to the very end. It is part of our answer. But now we're going to use difference of squares to factor what's in the brackets here, right? We got two terms. We're going to check if they're both perfect squares, and we have a minus in between. So it definitely looks like difference of squares. So this would be equal to our a squared value, right? So a squared is equal to 4a squared. So let's square root this now to solve for a. Square root of 4 is 2, and square root of a squared is just a. So our value of a is now equal to 2a. Easy. And let's check the last one, the b squared. So b squared would be equal to the 9b squared. So let's check that. So b squared, equals 9b squared. Let's solve for b, square root this thing. Square root of 9 is 3. Square root of b squared is b. There we go. So they both are perfect squares, and our b is equal to 3b. So last step, let's just fill this into our answer. All right, so our factored answer right from the beginning. Remember that's 4. We got to save that 4, so that's part of our answer. Then we have our two brackets. Hopefully it fits there. Our a value comes first in both brackets, so our a value is now 2a. So we go 2a, 2a, and then we have one bracket with plus, one with a minus. And again, the order of that does not matter. And of course, our b values, finish it off. Our b is equal to 3b. 3b, 3b. So our full factored answer here is 4, 2a plus 3b, 2a minus 3b. So yeah, if at all possible, always factor first, because at the very least, you're working with much smaller numbers. And sometimes you'll actually need the common factor before you can even apply difference of squares. Okay, so that is it for this one.